Hi guys, I hope everyone is well and having a great day so far. So last week I posted a video about carbon dioxide, and this is a follow-up to that lesson because I mentioned Sir Isaac Newton and I mentioned his third law of motion. So there's going to be another video that I'm going to post with this one that will kind of put that third law into action. So you'll actually see it. If you remember, I took Diet Coke Mentos in a small bottle. So anyway, we'll talk about that some more. By the way, Sir Isaac Newton, super interesting scientist. There are so many resources available at your public libraries that you could actually read about Sir Isaac Newton, learn more about him. So even though the doors are closed at your public library, they are still an excellent resource for you guys. All right, so let's talk about those laws of motion. Sir Isaac Newton's first law of motion states that an object at rest stays at rest unless acted on by an outside force. And an object in motion stays in motion unless acted on by an outside force. Sounds super complicated, right? So let's break it down. Let me get a prop. Okay, so I have a Nerf ball right here. So let's say we put this ball here at rest. There we go. All right, so if I leave, you guys leave, maybe we have a snack, maybe a nap, something like that, watch some TV, and we come back, is this ball still going to be here? Yes, unless somebody comes and picks it up or there's a big gust of wind, this object will stay at rest. Now let's imagine that I open my front door and I kick this ball as hard as I possibly can. Is it going to roll forever and ever? No, it will not, because there is a force that's acting on this ball as it rolls along the ground. That force is called friction. All right, so you guys put your hands together, rub your hands. Are your hands getting warmer? Yes, because you're generating energy in the form of friction. So as it rolls along the ground, friction will bring the ball eventually back to rest. So that first law of motion is also known as inertia, which by the way is a super cool word. Try to use it a lot today if you want to. So all that is, inertia is when you're in a car and you have to get in your car seat or you have to wear a seatbelt or whatever, you do that because of inertia. Because if the car suddenly stops, you're going to stay in motion because of Sir Isaac Newton's first law. All right, so I want to demonstrate that using a balloon and a hex nut. This is called a hex nut. Hex means 6. It has 6 sides. So all I'm going to do is put that in the balloon, blow up the balloon, and I've got one ready. So if you look closely, you can see that hex nut inside the balloon. So let's get that in motion and see what happens. That's crazy, right? So that sound that you're hearing is friction. As the hex nut goes around the balloon, it's creating friction. But let's get this going, and then I'm just going to stop moving the balloon, and let's see what happens. Okay, so why did it eventually go back to rest? It's because of that sound that you were hearing. It's because of friction. Friction over time was slowing it down, and then gravity pulled the balloon pulled the hex nut to the bottom of the balloon. Sir Isaac Newton, gravity, read about it. All right, so that's the first law of motion. Second law of motion, for all of you that love math, it's an equation. Force equals mass times acceleration. That sounds really complicated, right? All that means is you have to work harder to move things that are larger, things that have more mass. So I have a ping pong ball and my Nerf ball. Which one of these two things has more mass? The Nerf ball. Very good. So what I want to do is I want to try to get the ping pong ball to accelerate or move forward. So the force that I'm going to use is this right here. So if I turn it on, we've got air. So let me stand up here and we'll put our ping pong ball right here. Let's get this at rest. All right, let's see what happens. 3, 2, 1. Check it out. Brought that to rest. Okay, so let's use the exact same amount of force on our object that has more mass, the Nerf ball. So let's get this at rest. All right, 3, 2, 1. Uh-oh. So what do I need to do? I need more force. Well, thankfully, I do have more force. So let's see if we can get this Nerf ball to accelerate. 3, 2, 1. That worked. All right. Force equals mass times acceleration. All right, third law, my favorite law. For every action, there's an equal and opposite reaction. So again, if you remember, I have a small bottle of diet soda. By the way, use diet soda for that experiment because it doesn't have any sugar in it, so there's no sticky mess after. Put 1 Mentos inside, and the soda came out. Again, if you remember, that's because of the carbon dioxide that's inside the soda. Go back, watch that video, I explain it. So what I did to demonstrate Newton's third law of motion is I took a much bigger bottle of soda and I put 5 Mentos in it. So watch the next video and you'll see that third law. For every action, there's an equal and opposite reaction in action. All right, guys, have a great day and I'll see you again tomorrow.